Okay, this video will be over proof practice. I'm going to go over some proof examples for our chapter 7. First, we're going to be given Tx is a ratio over Vx, which is equal to the ratio of Wx over Ux. Okay, we need to prove that angle Tux is congruent to Vwx. Okay. To do that, we're going to have a goal. And our goal we have to look at here is we need to use similar triangles. If I can prove that these two triangles are similar, then I can prove that these two angles are congruent. So let's start with our given. We have Tx over Vx is equal to Wx over Ux, and that's given. Step 2, let's take a look at our picture and see what we can use to prove these two triangles are similar. So right now I have this proportion set up so that this side is congruent to, not congruent, but proportional to this side. And same thing here, Ux is proportional to Wx. And then if you notice, you guys, we have a pair of vertical angles. So now if I write my angle in, I have side angle side, and side angle side similarity theorem is what we'll use to prove the two triangles are similar. Okay, so we already have the two sides that are proportional. That's one requirement. All right, so the other requirement, so we have that checked off, is to prove that the angles are congruent. So we do have to say there are vertical angles first. So angle TXU and angle VXW are vertical angles. And that's definition of vertical angles. All right, step 3. Now that we know they're vertical angles, we can say that they are congruent. So angle TXU is congruent to angle VXW, and that's by the vertical angles theorem. So some review from last semester's proofs. Alright, so now we have side angle side, and now I'm able to say these two triangles are similar. So let's say triangle TXU is similar to triangle VXW. Alright, and that's by the side angle side similarity theorem. Okay, so you do need to have the similarity symbol because we're not looking at congruence, we're looking at similarity. Now we can write our last proof. So remember, for two figures to be similar, their corresponding angles have to be congruent and the sides must be proportional. So TUX, angle TUX, is congruent to angle VWX. Those are corresponding angles. If you look here, TUX and VWX, and that's by our definition of similar triangles. Okay, and QED, check mark, we are done. Okay, let's take a look at another proof. This example, we have QT is parallel to RS. All right, so let's draw that in. QT is parallel to RS. And we need to prove that PQ over PR is proportional to PT over PS. Okay, so we're looking at this small triangle here. And we're looking at this large triangle. So we need to prove, so again our goal is going to use similar triangle. Use similar triangles. Alright, so again let's start with our given. QT is parallel to RS. Alright, step 2. Okay, if I know that these two are parallel, remember we can use all those angles that come with parallel sides and a transversal. So if you remember, I'm going to mark these two angles. QR or angle Q and angle R are a pair of corresponding angles. Okay, so this pair, if you remember, as long as they're parallel, I can say that these two angles are congruent. So angle PQT, so this one, angle PQT, is congruent to angle PRS, and that's by our corresponding angles postulate. Alright, so now let's take another look at our picture. Right, we need to prove that these two triangles, the small one PQT and PRS, are similar, and I have one pair of angles already marked, but they also share angle P. Right, so automatically angle P is the other angle we can use. So now I have angle. And let's say angle P is congruent to angle P by our reflexive property of congruence. Right, we're using congruence. Alright, and now we have enough, because remember angle is one of our similarity proofs, or theorems that we can use. So we have triangle PQT is similar to triangle PRS. Right? By our angle similarity, I believe this is a postulate. Right? And step 5, now I have enough information because all I have to prove is that these are similar to say that the corresponding sides are proportional. So PQ over PR is equal to PT over PS. Right? And it's again by our definition of similar triangles. Alright, QED, and we're done with that proof. Okay. Alright, let's try one more example. I'll zoom out a little bit on this one so we can see. Okay, so this third proof, we need to talk through a little bit before we start. Alright, so if you check on your yellow worksheet, this is the same as number 2. So this should help you on those proofs. Okay, so again, our goal, alright, this whole unit is over similarity. So if you can guess, our goal is going to be use similar triangles. Okay. Alright, so AB is perpendicular to BF. So I'm going to draw in that right angle. Right. RH is a perpendicular bisector of AF. So that means it meets AF at a right angle, and it bisects that segment into 2 equal parts. And then we're also given angle ARH is congruent to FAB. Okay. All right. So when I look at this, I need to figure out how can I prove that these two triangles are similar. Because if I can prove they're similar, then I can say their proportional sides are equal. So let's look at what we have. So we have an angle, and another angle. So this one we can use angle similarity. Okay. So let's start with our given. This one I'm going to break the givens apart. Take it step by step. So AB is perpendicular to BF. And that's given. Right? So then I need to say that this is a right angle. Right? So since I said they're perpendicular, I can say angle ABF is a right angle. All right, and that's our definition of perpendicular lines. Okay. All right, and then let's use our next given, that RH is a perpendicular bisector of AF. And that's given. Okay. And I need to figure out how I can say that these two right angles are congruent. So if we know it's a perpendicular bisector, then we know it's perpendicular. So I need to say that AF, because it's a perpendicular bisector of AF, is perpendicular to RH. Okay, and that's our definition of perpendicular bisector. Okay. Step 5. Now I can follow the same process as I did up here. I can say now that angle AHR is a right angle. By definition of our perpendicular lines. All right, and then step 6, I need to say that those two right angles are congruent. So angle ABF is congruent to angle AHR, and that's by our right angles congruence theorem, which states that all right angles are congruent. All right, let's use our other given so we can say that they are similar triangles. So our other given is angle ARH is congruent to angle FAB. And step 8, I now have enough, here's my angle, to say these two triangles are not congruent, but these triangles are similar. So triangle RHA is similar to triangle ABF. And that's going to be by angle similarity postulate. I'm going to squeeze one more in here at the bottom so we can have our proof statement. Alright, so now we can say that HA over BF is equal to HR over BA, and that's definition of similar triangles.